Hey guys, it's Vince. Today in this video, I'm excited to discuss the Hesperos Corporation custom CNC enclosure design that I've worked on with Singith, who is my contact over there. He is a scientist slash engineer, and this design is actually what he came up with, and we worked together to make sure that the unit was as close to plug and play as possible for their application, which this unit will be actually designed with the robotics that they have in-house to basically cut and work with human tissue. So this is really interesting design. And again, a very, very neat design as far as time-saving features for my end users, because this is something I wanted to point out to you guys because I get questions all the time on custom enclosures. You can see here we've got 36 holes in sequence, and these are designed for DIN rails, and they are all tapped for M5 screws. Okay, so you've got full adjustment all the way across this enclosure. The bottom hole pattern matches GR214 Raptor drives. So again, we already know he's going with Raptor drives. Now, with this enclosure, of course, I can modify these holes to match any drives that's required. But one of the most unique features about my enclosures, and I went over this with Singith, is the fact that I make them so they all break down. The frame you see before you all breaks down. You can see the screw locations right here. And I feel that that offers the end user the most optimal way to assemble their controller. It makes things easy. You guys can work on one piece at a time, keeping things as neat as possible. And if you're doing trial fits on anything, it makes it that much neater. I just didn't disassemble these frames here. Now, it appears in the video that we have a gold anodized coating on here. We do not have any anodized coating. It's an EMI solution that the controller's enclosure is dipped in. So again, this is aluminum. It's not steel, so it's very light. That saves you money on shipping, makes it much easier to work on and service. The other thing I want to point out is the lid. It's all one piece. So you can see right here, it just slides on and off more like a computer case. So again, you can see exactly what we have here. And that's all set there. Now coming to the front and rear panel of this enclosure, and this is where things get really interesting. You can see, actually come around this way so we can give them more of a view to see exactly what we have here in terms of GX16 ports. We have 5. We have 5 on top, 5 on bottom. Then we have DB9 ports. And then we have our 80mm fan ports, Ethernet port, for whatever Ethernet controller he's going to use. We then have our e-stop port, and then we also have our power switch port. Okay, these are all pre-done. But where it gets interesting, and where you guys are like, okay, well, it's all machine, that's great. You can see it breaks down, that's great. But what really makes this interesting is the fact that if you guys require switches, and in his case he does, he then uses my GX16 4-pin solution switches. Now, again, the 4-pin is designed for proximity switches. This is what he's chosen to use. These are all pre-wired, 18-gauge silicone wire. And of course, they're going to have ferrites, which I'm including in the kit, installed already. So what does that mean to you? Well, I'm going to show you what it means to you, because this is where I think becoming more visual, things get interesting. When he receives this unit, essentially all he's going to do is insert these wherever he decides to mount them. And this streamlines the entire build process at least 80%. As he already knows, he can select wherever he wants to mount these ports. Okay? So he can adjust his dust covers, because I include them. I'm one of the rare vendors that actually include them, because they should be included. And you can see he could select top row, bottom row, a sequence of rows. He then has his DB9 connections for whatever other signals he plans on working with. And again, this entire enclosure visualizes how simple it can be to design your own system. And that was why I did these, because GX16 wiring is very, very tedious. You figure right now, just with these 4-pin connectors, 4 times 5 is 20 leads right there, and they're already done. So he would naturally just come in, put the ferrites around here, space them accordingly, which I'm including. So again, frequencies are all met, and then he just wires these into whatever connectors he'd like. He will, of course, have to terminate to a ground bus, which again, I am including. Now, the cool part about this enclosure, and this is something very interesting, is that once again, it's using DIN rails. So with it using DIN rails, that allows us to mount all of our accessories, like our toolless mounted ground bus. He's got 2 of these. You can see how this works. We have our 6/32 screws, and of course we have a washer and a nut, and that would just naturally go through one of the holes. He would then mount this in a traditional enclosure. However, he's using DIN rails. So we bought DIN rail adapters, and knowing that he requires these DIN rails, it's very, very simple for him to just mount these on the DIN rail adapters, and then he'll use this hole pattern over here to adjust the exact location he wants to install these. So again, very, very simple to do. And you can see our spacers, once again, giving us proper height so that we have clearance of all of our screws. And once these go through and make contact with the enclosure, he then has conduction and proper grounding through that. So again, it does not get any simpler than that. And to give you an idea of the ferrites installed, seen my fail video series, and you see how many guys fail endlessly at, once again, either using double shielded cable for all of their step and direction leads, or they typically just do not use ferrites. Ferrites provide passive filtration. And you can see here how they're properly spaced. Now, if he cuts these leads back, or you would in your system, you would naturally either need less ferrites, because again, the distance is once again shorter from where the access point is to the double shielded cables, or you could leave them on there. I mean, you can leave them on as many as you'd like, but typically you like to keep them spaced between 6 to 8 inches apiece. These would naturally just slide in. And once again, these are my pre-made GX16 5-pin using silicone leads. You have your green lead for your ground. The rest of these are for your steppers. And again, 4 lead steppers. Now you see where the 4 leads are used. The 5th pin is once again allocated to the shield drain, which would be right here. And you can see how easy this is for him to build. He just throws these in wherever he'd like, and he can manipulate these to once again support as many drives as possible. If you have a 5-axis system, he wanted expansion, he's definitely got that here. So again, it gives you guys a visual perspective of what's possible and doing it in a very, very quick format. You can see these are insulated properly. Everything here is done. All you have to do is remove the nut, drop them into the hole, and you're all set. Now, he asked for a custom part. He wanted to have, these are 80mm fan ports. He wanted to have fan port covers made. There you go. So he has covers for these ports if he's not using them, or he wants to put them on for whatever reason. He's all set there. These are done as well, and they are dipped as well. So again, looking at this, you guys can see all bases were covered. And I'm just going through now. Now, mind you, he paid to have every connector included, including DB9 solderless connectors, where he's going to install the DB9 board right back here. Now, why would he want to do that? Let's cover that real quick, because I get guys that'll ask, you know, you're putting it in the video and you're covering a lot of detail, but I'm not seeing what you're talking about visually, so it makes it hard to understand. Let's make it easy to understand. Let me show you what I'm talking about. Just give me 1 second. You can see what I'm doing here. I'm just taking out the set pins for the solderless connector. Now, DB9 RS232 connector is very simple. You can see we have our pins, and the terminal blocks are all numbered. You got a ground terminal, you have 1, 2, 3, 4, and then on this side, you have 5 through 9, okay? Now, when he wants to mount these, all he has to do is drop these in. Now, he's just got all that done for him in terms of having to wire these, because once again, these are solderless. And you can see he would just put jack nuts there, and those jack nuts lock this into position, and he would just plug in the cables he requires. So these ports are all set and done, all machined, and he's ready to go. Okay, but looking at this dismounted from the chassis shows you how easy this is to work with. I've shown you in all of the fail videos how many guys have trouble holding GX16s. Now in his instance, of course, he's got my pre-wired versions of GX16s. Let's say you didn't have the pre-wired versions. If you needed to hold the GX16 for mounting, once again, all you would do is drop it in to this hole, or a hole, for instance. It's arbitrary, of course. You pick which way you want to go. We just bring it in, drop it in, and you would temporarily lock this by putting its nuts in place, and then you could hold this back plate in a vise with rubber jaws, preferably, and do all your soldering. And that makes things much easier, as the back plate essentially becomes the jig to mount your components. So when I'm telling you guys that engineering counts, it really does. It does for a couple purposes. It does for the fact that naturally you want to build a stable controller. And once again, I feel that's why Singeth came to me. He realized that I'm putting a lot of effort, and I do have a lot of passion in what I do, because this is what I've chosen to do for my profession. And he realizes that it's real. Everything I'm discussing is real. We went over that. So he made that choice that he didn't want guesswork. He wanted to do it in a fashion that is very easy for the additional scientists he worked with to assemble these controllers. And now you can see just how easy this is. We've seen videos in the past in my CNC fail video series. Guys are drilling holes. They're doing all kinds of extra work. In this, you really don't have a lot to do. Yes, he did pay for this. I'm going to tell you right now, the labor involved in this is extensive. But if you're serious about hitting the ground running, then these are the chassis for you. And I cannot emphasize that enough. Right down to the power switch, even having its centering joint. You can see it right here. That little notch is to center the power switch once it's inserted. So again, all of this is done. It's completely done. All he has to do is screw everything in, do the final assembly, and he's golden. I tried to make it so complete, in fact, he gets his wire ties and hold downs. You can see everything is numbered, so he knows what he's got, and he can go through and do whatever he's required to do. AC terminal splitter. Once again, simply labeled, very easy. His scientists do not have to do a lot of work. We have here bridging done. Why do we have bridges done? Because we want these terminals right here to all be allocated to live. We have all these terminals here allocated to neutral. We have all these terminals here allocated to ground. Very easy. Very easy. It's perfectly labeled once again. And when I say perfectly labeled, pan over here and show them the equipment. Right here is an Epson P7000 printer, and that's a Suma T75 series cutter, tangential head. Okay? So once again, you see the equipment I'm using. This is the difference between you guys getting the results you want. And again, these are toolless mounted. You can see how the cover is held in place. And this will once again be mounted on the DIN rail mounts. So these can be placed in any central location they choose on any of these pre-tapped holes. Okay, so it's endless. If you guys have an idea, I'm going to tell you how fast we did this, because I'm very impressed with this, considering how it came out, and you can see exactly how it came out. This took just under 2 weeks to go from drawing to right here in front of you, and it's dipped. Anyone will tell you right now who understands manufacturing to go from a prototype to full-scale rendition where this revision is ready for delivery in that amount of time is pretty impressive, including we're actually dipping in an industrial solution. So thinking about that and showing you the results, I think that speaks for itself. And once again, he'll be getting a copy of this video to see for himself, because of course I want them to naturally be happy. But this is the same process I use for every client. Whether it's a client that worked for NASA, whether it's a client that worked for Hesperos, whether you guys contact me, this is the difference I feel that I should execute. I don't talk about using certain types of processes and not do them myself. You see, everything here was done and no corners were cut. He said, you know, like many of you say, well, I need more than 4-axis potentially in the future. We'll go with the 5th. Well, I might need an additional DB9 connector. Well, I need to go with that. I'm going to tell you another portion of this design that was very interesting. In the first week he gave me the drawing, he made a revision change on this cutout right here. Now, once I get this drawing done and we're starting to do the machining process, of course, I'm very, very, very weary of taking any revision changes, because if this is done already, you've lost money on the plate. We even got the back plate done a week after he made a revision change. Okay, now I won't do that on every order if it's already been in the shop and we're getting there, but this is imperative that in their case, if they make a revision change, they need it. And I realize many of you do that. You'll see something and say, hey, you know, I need to change that on the fly. I try to work with my clients as much as possible. How often does that happen?
Often.
Yeah. So something is mismeasured, we go back and we make sure we can get things right. But looking at this, once again, it shows that all bases are covered. And the other thing is, and I say this not lightly because many guys forget this, just because I'm including the GX16 connectors does not mean we're not including all the females to go with it. Now, I'm going to tell you guys right now, had he said, Vin, I want to buy pre-assembled motor cables for this system, I already have 18 gauge double shielded cables for him or you if you decided, hey, I want a system that's virtually done. The only thing I have to do is screw in my drives and do the final wiring. That's about an 85% reduction in labor. And anyone will tell you that, especially when you're factoring in all of the soldering being done and done correctly. You can see they're all insulated. Everything here is done, and we're using silicone leads. All you would do is snap on your included ferrites and you're ready to go. And this is once again for the GX16 4-pin switch connectors. But it's endless. And that's why I'm telling you guys, I want you guys to think about what you're getting involved with. Watch those CNC fail videos. And I have more and more guys messaging me and saying, I want to see more builds. This is just the beginning of what you're going to see. But it does show you how easy it is to go from prototype to, once again, a full-scale release revision. And this client, I think, is going to be very happy. Again, we do have 2 fan ports here. I've gotten asked about this before. And we're going to go with, once again, a push-pull. I call it a cyclonic action, where once again we have one fan bringing air in, one fan bringing air and heat out, and that is optimally the way to go. Now you can also see the lid is solid. So when this enclosure is closed and all these ports are filled, the only way that air is going in and out is from these 2 ports, and he will be using metal fan filters. We already covered that. So again, totally done. Ready to go. One of the questions that I always get asked is, what size enclosure can you build me? I can build any enclosure you guys require. Right here, you can see we went with a 14-inch long by 10-inch high by 18-inch wide enclosure. So this is closer to like a rack mount for a server. But again, we went that big because it gives him a lot of height. He can work with different components in terms of how he mounts things if he does want to stack anything. I do want to show you once again, here is the DIN rail mount. And again, this accessory allows you to convert standard accessories like ground bus, and he can use this to mount it on a DIN rail. You can also mount them in sequence. You put one ground here, one ground there. He's got 2 of these, actually he has 4 of these, excuse me. So again, easy to mount components. Then he needs wires. Okay, when I say wires, I'm talking about the leads going to any accessories he wants to wire. Do you have that in stock? I have everything. Here's 10 different colors, and this is 20 gauge. And again, these are 26 inches in length. Now this is what he requested. So think about the time here with this all being done. And it's all pre-bagged, ready to go. Then he needs 16 gauge. He's going to wire in his power supplies. Everything here is set, 4 colors, 36 inch, 16 gauge. Break down the amount of time you're looking at. And I'm telling you right now, you will soon understand how much you're actually saving. When we look at the CNC fail videos and you see their average video length is 30 minutes, I can tell you right now, that's usually around between 4 to 6 hours of build time. That's what you're looking at. This will shorten that down dramatically. because once again, you can separate your components and work on everything in a systematic fashion as you should. So again, everything here has been tested for continuity again before it leaves the shop to make sure everything is once again fully conductive. Fluke 179 True RMS multimeter. When the unit is assembled, it's assembled with a torque screwdriver. Now, many of you guys have asked me about this. How it basically works is just like your drill. When this actually screws and reaches its proper torque setting, it will just disengage. And that prevents from any stripping to happen on the enclosure. And this is what everyone should be using, especially with the robots as they're assembling it, to make sure that the pressures are all the same throughout that robot. And of course, Loctite on any screws that once again are be subject to vibration. So you can see here, this is an elaborate production. Now I'm going to assemble this unit and I'll show you exactly what it looks like when it's assembled. All right, guys, this is the enclosure assembled. And again, you can see now how high it is. I'm going to show you how a torque screwdriver works. Many of you are familiar with this, but those of you who are not, you can see it just locks. Come in again. Done. You don't worry about stripping anything. When you're working with precision stuff and you don't want to strip anything, these are your best friend. So again, we can see the back plate. You can see the height. There's nothing here going to limit him from building with more real estate vertically. And I tell guys that all the time. A lot of times in my system, you see guys just use the horizontal real estate and nothing vertically. That will work out really well as long as we don't get crazy mounting 4 or 5 different power supplies in the system. There's no sense to that when we're dealing with the amount of EMI that it takes to corrupt your step and direction signals. So once again, that's where you really want to think about how you're going to engineer your system. And this type of enclosure certainly makes that easy. We'll go around to the front now and I'll show you exactly what it looks like. You can see how clean everything is. And once again, we're done here. He's all set and he will once again build the unit. I'll show you the bottom. So you can see all the tapped holes and all the mounting holes once again for Raptor drives. And again, I will state that if you have a different drive pattern, we can change this. So it's really up to you as far as what drives you want to mount here. But overall, I get requests for DIN rails all the time, and it is a very easy mounting platform. And especially with these being tapped, you just adjust them as required. So you're almost basically working with a PC case in the sense of, once again, simplicity. So again, guys, I hope that this video has got you thinking. If you're looking at building your own system, there are ways to do it in a much more simplified platform, doing it with components that are already pre-done, pre-tested. I mean, my stuff has been on the market now for well over a decade. You really just want to make sure that what you're purchasing has exactly what you need. And if you supply me a drawing or you even have an idea, we can schedule a consultation, which is exactly what Singeth and I did, and we can go over the design. We'll implement whatever you need to understand, and in this way, you'll be basically on the right path right from the get-go. He'll be able to receive this. His scientists, once again, don't need to know everything I do, as the machining's already done. Everything has been included with the system. He's going to help guide them to some extent. And of course, if he has any questions, I'm always there. No different than for you. So I hope that the video has been helpful. Come back here. You show him this again. And again, if you guys have any questions, you want anything custom done, I am there for you. Now, once again, Singeth is ordering multiple of these units. This is just the beginning. They are converting basically their whole lab over to working with now automated robots. So in the future, naturally, this is a one-off and will stem to a larger production as far as ordering more in quantity. You guys, whatever you need, depending upon how many you need, because I get that question too, I'll do my best to work with you on pricing the best I can. Once again, I want to thank you all for your support. Take care.